Hello, my friend. Welcome to my amazing lesson. But it is maybe like quiz, okay? It is not like lesson, maybe. So I don't know what you will find in this process. So just really, you can reach some kind of state in this lesson quiz or whatever. Anyway, you know better, right? Yes, May. We will start to do this together and we will solve five questions. Then we will check what we done. Yes, just think, okay, we're doing quiz, we're doing exercise. It's really making us stronger than before. We knowing things. We don't going to forget too much things. Normally, yeah, your brain is forgetting things because why? There is some mentalities. I mean, it's there is we have neurons and we have. So also, I will I will speak about machine learning, but it will be a little bit robotic, but anyway, I will speak about humans. We have neural networks, it's the same system. It's not like that, but anyway, we have acros and we have amygdala. It's amygdala just want to take good information. Like just think, there is a one teacher, he's just reading or she is just reading all the information from book, just like a civil engineer is writing the code to calculate the center of gravity, like that. And one man also, the otherwise, I mean, the other teacher is doing. A civil engineer is writing code and doing some kind of uh, behaviors, and really, it's just making you, hey, oh, really, I have to watch this man because he's playing like monkey. Then I can learn lots of things. This is the reality, man. Anyway, this is the way to learn things. But anyway, I'm not monkey, okay? I'm just, I'm just, I'm just, I'm just nothing. Anyway, let's go. I'm happy because I was make vaccine, so for my hand, I'm a little bit crazy. Anyway, don't touch me too much. Let's go. First question. The first question will be what? What do you think? First question. A civil engineer. Mm-hmm. Engineer. Civil engineer is writing code to calculate. Is writing code to calculate the center of gravity for semi semi that's why it's semi ellipse. You can think it like cylinder, maybe not, maybe it's, yeah, anyway, it's because I know formula it's like for not for, I mean, the radius you multiplying center by time radius and divided 3 time p. Anyway, it's some physics formula. Anyway, now I will show you all. Okay, don't worry about that, trust me. Okay, let's come here, let's go a little bit this place. Yes, yep, let's say radius, and really you can do something like that. Let's say this one is some rounding number, I mean float number. Okay, but we don't have there some rounding errors. Okay, we will speak about different things. For now, just don't think too much about that. Let's come here, say center y. Yeah, let's take it little there. Yes, and go there. Yep, this one is little long. Let's say four time radius. Yes, radius divided division 3. So let's put it then the time t t. Okay. Now what I want to do, I will do it here. I will make things like why I'm bad about drawing, man. Four. Why this is too much bigger, man. Four. My four is very bad. I'm sorry. I'm so sorry about that. What is it? Yes. Four and radius divided three and time p. Okay. This is our formula. Okay, right here. Let's now. I will make other place to solve this situation. Let's wait me. I will take my phone this side. Yeah. Yes. Yeah. 1 minute. Okay. Let's do it. Let's come and do it together. I got some songs from outside anyway. Don't worry about that. So, uh, let's come down. I will write again. Okay. We will write lots of things. Just don't worry about things. And I'm doing here things right there. The court release on the building. Yes, by running the set by running the same. I'm sorry, the sum calculation on their on their on computer on computer. I think there is different computers on computer. Their program results. Their program results in a center y of 14 and mm, 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 mm. Oh, I don't like to write these numbers again and again. Okay, just this place is important. Maybe I can maybe right really. Yeah, I will do different color for indicate. Okay, let's say let's come here and do it like this color, and this one also will be same. Let's tag it like that, this color. Okay, this is that. Because now we will compare two numbers there to run. It's looking like rounding numbers, right? Anyway, now let's say the 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 a minute the two values very close, but but not quite not quite the same, right? The same. This is the problem, you know that, right? Let's come down. We don't have too much place here. Mm-hmm. Okay. Then, which of this, which of which of this is the most likely explanation for the difference? Explanation. What I am writing there? Explanation. Explanation for the for the difference. Okay, this is the question. No, anyway, I will write all of them, then we will speak about details because it will take lots of time. If I didn't, let's come here. And yes, maybe this place will be good. We have D and we have E. Okay, let's come down. Let's write our answers or options. One computer used one computer used an integer representation for the mm, for the numbers, while the other computer used it while the while the while the yes while the uh, other computer used more other computer used to to more accurate yes more accurate floating point representation floating point point representation. Okay, anyway, we will speak about that, but don't worry, just go again other one. Let's write here the two computers represent the constant. The two represent computer represent computers. I'm sorry. Computers represent the constant p, the constant p number. I mean, with a different with a different level of different level of precision precision due to due to their rounding strategy or rounding strategy or what is that? Size limitations. What do you think? Yep. One of the computers has a bug in one of the computers. One of one of the computers has a bug. Has a bug in its its in its mathematical operations. I think this is bullshit. This is not true. Let's go other one. Let's say the other one is like what? Kind of stupid words. Sentence. The two computers executed. The two computers. The two computers executed the arithmetic operation. Executed. Executed the arithmetic operations. The arithmetic operating operations. Mm, using a different order of using a different of where is it of different of just one word operations. Operations, right. Operations. This one is that. The last one will be one of the computers experience it. One of the computers experience it an integer overflow error. Experience it and it. An integer overflow error. An integer overflow. You know what is it? Error when calculating the result. Calculating calculating the results sorry. Okay, this is that. Okay, now let's make bigger. But this one is a little more bigger, right? What do you think? How we can come little bit? Can we change this like 90? Oh, let's say, oh, maybe a little bit more. Maybe little bit more than more. Yes, I think it's okay. Okay, let's look at this informations. What we will find here. A civil engineer is writing the code to calculate the center of gravity for a semi-ellipse. Okay, semi-ellipse. Like you can think, where is my? Oh, right here. Just think here, and just think this one is. We will calculate this place, semi, right? Gravity, this place, and anyway, we have radius here and center y. We have. So then we're doing some calculations here. Okay, this is not important. We are not in physics lesson. So the code really is the built-in by running the same calculation. Same, I think. This is not some. Sorry. Same calculation on their own computer. Their program results in center Y 14 at point, blah, blah, lots of numbers there. But what happened, here? I think I forget to put there one information. I don't know why I forget it. Uh, this one is get information, but before that, right? I just forget it. The code release. Then we sang stores. Where is it? The code release. Built-in custom period after. Oh well, what I did here, man. Release built-in by running built-in, then I'm writing something different. Oh, after P, where is the P? Oh, okay, man. Now I have to change here. By running built-in constant, there is anything like that. Anyway, let's go down. Built-in constant. I'm so sorry, really. I read lots of things and my brain stopped. Constant. Then let's say P. Okay. No, this is constant P. What I'm doing, man, here? Okay. I remember I was put here one P2. Where is it? This P. I forget or what I delete of. What happening, man? Anyway, say P after running the code center Y Let's come here. We will check. Yeah, the result. Where is the result? By running the same calculation. By running the same calculation on computer. No, on computer. On computer. Their program results. Okay, this place is also wrong. Here, let's delete it. Let's let's write this place. I will write till there. Okay, let's write this place. I'm so sorry, really things is mixed here. There. Okay. College. Okay. Checks the result. Check the result by running running yeah, by running the same the take it down now. The will be crazier now. Same the by running the where is the same calculation. Same calculation on their their own computer. Computer. Okay. Okay, now I solved it. Now I will put here also this again, this same number. Just what will be different, Just the last two numbers will change. The last two number will be 57, I think. Yes, 57. This one is 25, ending with the 25. This one is ending with 57. Okay. Now let's solve together. Anyway, we said all of them, and we sang the code release the build constant p after running the code center wide stores. The one computer is running and it's taking this solution. The just p number is here and information here. The colleges checks the result by running the same calculation on their own computer, not computer. It's computer, right? Their program result in center y of 14 and some number end of so and like 25, last two 25. So this is really not different normally, but it's different. Okay, if you are sending some rocket to universe, it is important. But if you are working for some kind of normal life projects, it's really not. I don't know. Really, it's your choice. The two values very close but not quite the same. Of course, we know that. Which of this the most likely explanation for the difference? Which of this is the most likely? I think there is also two one words missing. This I think true. Which of this is the most likely explanation for the difference? Sorry, it's not true. Right. So now let's come down and let's look at here. If you want, I will do it. Right. Let's look at the answers. We know, right? Two number is different. Last two numbers. One computer used an integer representation for the numbers. Really? Let's take pencil. Let's make it green. Just I want to put there. So sign. One computer used an integer representation for the numbers, while the other computer used the more accurate floating point representation. So one computer used an integer representation for the numbers, while the other computer uses the more accurate floating point representation. No, it is not that. This is totally wrong. There is no integer represent like this, something like that. Okay, so other computer, all so two computers doing same operation. Just there is maybe anyway. Now I will read it. The two computers represent the constant p numbers. I mean constant p with a different level of precision. This is the key here. Due to their rounding strategy, let's check it. This is K. Yes. Or size limitations. Yep. Yes. This is the, I think, K point here. This one is true. I told you. So because it's saying two computers represent same constant as P, we know that, right? We saw it because I think some person is reporting and then saying, hey, we are doing same operation, but why different is? Yeah, there is maybe rounding strategies different, or so maybe precision problem, maybe size limitations. It can be there. Anyway, the other one of the computers has a bug, and it's mathematical. No, it's really not. The two computers executed the arithmetic operations using the different of operations. This is not true. This is some lie. One of the computers experienced an integer overflow error when calculating the result. One of the computers experienced an integer overflow. Integer overflow. Okay, but the other computer doing same operation. How one computer can do it only? Oh, it's not really. It's not an overflow error. That's come here because we set here limitation, rounding strategy, or precision. We have three answers there. Now we will look our other question, but before other question, let's put here also this thing and like that. And okay, let's come down. Let's not come too much. Yes, to put here anyway, one S for indicate place. Yes, let's do two. Which types of data are stored stored on a computer using bits? I think maybe you remember this question. Maybe I'm not sure. Okay, let's come little here. Let's put it something like that. Okay, let's say the first one, we can say this is, oh, really? Yeah, this one is first, say whole numbers. Other one, say two, for that. It will be fractional numbers, fractional numbers, and three text files. Let's make it bigger also. Why I did the bigger that? Anyway, let's change it. Numbers, just small. Okay. Okay, and okay. Come down now. Say, uh, the, uh, the one only. Say for B, one and two only. Let's say for C, two and three, not A, B, D, and three only. For D, let's say one, two, and three. Okay, let's look at this question. Which types of data are stored on a computer using bits? Bits. This bits. This is the key. The computer's only using bits, guy. There is no other thing. It's just bits. It's representing numbers, floating numbers, fractional numbers, rational numbers, whole numbers, text files, game files, sound files. I don't know really all GPU, no CPU files. So all of binary files and device, all device use. Just think, you have USB, and this is also a file. Okay, all things is just binary numbers. It's bits. Let's say this one is no, 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 and this one is true because all of them bits. Bap, bap. Yes. Let's come down. This is our 2, and we will look now for 3. Yes, here. It's 3. We'll say film scanner is a device that can is a device that can that scan sorry that scan photographic 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 film and save it. Film and save it. Yes, as a digital image. Resolution of a film scanner. The resolution of a film scanner measures the number of dots to the measures the number of dots. This is the K number of dots per inch. Yes, per inch, no inch. Inch, inch, inch. It is representing with DPE. It's short case, and that it. So dots per inch. I mean, this one is dots per inch. Okay, that it captures. That it captures. So we can think like what, if the dots per inch, so number of dots per inch increasing, our quality coming up. If the decreasing, just you will watch there's some shit. Then you will cry. You will say, "Hey, what am I watching, man? Just close this television or phone or I don't know what." Anyway, let's come and say the table list list lists the resolutions of various film scanners. Yes. Now we will write together. Let's come down and really we will look some information here if we can. Let's say this one is scanner and go a little bit far away. Let's say this one is resolution. Yes. Let's put something like that. It's really no matter what is it. Yes, come down and say brown. It's I think German words really. It's like brown. They are saying like braun. Braun. I don't know why brown. I'm also learning German. Braun. No. Nova scan or Nova. I'm really sorry. Okay, I don't know scan scan. I mean Noah. Maybe Noah. Noah is not Noah. Maybe it's Noah. Maybe not. I don't know. Nova scan. Okay, I will tell like that. If the company is different, just don't report me. I will change faster. Okay. This is this is just how you gonna say containing. Oh, right. I think this is the good words, right? Containing 1,800 number of dots per inch. So DPE. I mean, okay. Let's say DPE. The other one is Pacific companies looking good. Image. I don't know. Maybe you know this companies. I don't know. It's very good. I want to watch something from them. This is 10,000. That's per inch. Let's come the other one. Plus stack. Plus stack. Plus stack. Optic film. Optic. I don't know. Optic film. Mm, is something like that. They have also good. Really, it's 7,200. It's good number for dots per inch. Okay. And the last one is looking Veho. Veho. If you see, 14. Seth. Come here. This one is, yeah, all information is that, guys. I hope you like that. Which one you want to watch? This one? And so, fourth, third, second, first. Which one? Just like that. I want to watch with second. It will be amazing. It will be 4K, 4K. How you gonna say? Okay, that's right here. Which of the following comparisons, which of the following comparisons between comparisons, not comparisons between between scanners is the most likely? Scanners is the most likely. Oh, likely, not likely. It's likely, most likely to be true. That's to be true. Our question mark. Let's come here now. Okay, let's write it again. First one is saying the Veho scanner may miss some details of a scanned document that the plus stack plus stack scanner captures. We will look together. Don't worry about that. Wait me there. B is like the Pacific The Pacific, not small, not small. The Pacific image prime, I think. Prime, not image. This is not prime. Image scanner may miss some details of scanned mm, document. Again, same information, I think. Segment that the vehicle that the right vehicle scanner misses. Yeah, we will check, but I think I'm writing wrong. Captures, no misses, no misses. Captures, I have to be careful. Let's come down and look the other one. Let's say, see the brown, the brown. It's German. Don't worry about that. Scanner may capture some detail. May capture some details of scanned document of scanned documents documents document that the plus tag and that the the plus tag, let's write bigger, plus tag plus tag scanner misses. The last one, the brown scanner may capture the brown scanner may capture some detail of may capture some detail of scanned document at the Raho scanner misses. Okay, let's check step by step. I will check my pencil here. Let's go up. It's saying which of the following comparisons between scanners is the most likely to be true. We are looking for true comparisons. We will compare them right now. Okay, let's look at that. The Weho scanner may miss some details. Weho is that one. Some details. Let's take it a little bit up. We can see easy. Yeah. The Weho Plus scanner. So Weho scanner may miss some details of a scanned document that the plus tag scanner captures. Where is the plus tag? Yeah, I think that's true. What do you think? Plus tag is have dots per inch, 7,200. This is good. And this one, Weho, is really can miss some details there. So I'm thinking like that. What do you think? I think it is like that. This one, if you ask me, this one is true. No. Yeah, right. This one is true. Warehouse scanner really will miss some detail there because this dots per inch is not too much. If you said me, if you had so if you tell me, hey, Pacific, then I will say okay, but so brown and this Waho is really not true. Okay, we know now other ones is false, but I will look again. As other one is like the Pacific image, not imager, but anyway, this is image. Again, image, two image out there. Anyway, Image scanner may miss some details. Pacific imaginary, right here, there. Some details scanner document that the Wahoo scanner captures. It is really not true because Pacific Image Prime have those per inch 10,000. That's per inch, and this Wahoo have just 3,200. Is really not too much, and this one is like highest than this Wahoo 6,800 more dots per inch. So this is false. The Brown scanner may capture some details. Where is the Brown? Brown is the just last one. Anyway, last data there. Of scanner document that the Wahoo scanner captures. It is wrong. So no, 1 minute. Right, it's wrong, but I will check it. So the Brown scanner may capture some details, whereas right, yeah, that the plastic scanner misses. No, this is wrong because plus tag is bigger than a. The Brown scanner may capture some details. Second, document that Brown scanner. Really, this is also not true. So this is the our answer. Let's come down. Other question is that one. Consider this sequence of bits. Yes. Now let's write 1000. Yes, 111001011011. Other one is 0011100010001110. Other one, it's 11101011001111. Other one, 01100100001010. Last one is 1011100011000111. Yes. Now let's think what is the true what is the true about this binary. Yes, about this binary data. Okay, let's say the first one is saying this sequence of bits may represent this sequence of bits may represent positive numbers, but it could not represent represent it could not represent any negative or fractional any negative or or fractional number. Oops. This is really wrong. This is not true. I'm angry because I saw it. B will be the sequence of bits may represent positive and negative numbers. Let's tag these words. Just put there. I don't want to write. And negative numbers represent positive and negative numbers, but it could not. But it could. Not ETG. It could not represent any fractional numbers. I don't know why they have problem with fractional numbers. This is the heart of programming, heart of binary data. How we can represent our numbers without this fractional numbers. The rounding problem starting with this data. Anyway, C will be this sequence of bit may represent positive, negative, or let's tag this one. Negative. Yes, negative or fractional numbers. Anyway, I will go on again. This sequence of bit may represent positive numbers and fractional numbers. Let's tag this again. And fractional numbers, positive and fractional numbers, but it could not represent any. But it could not represent any negative numbers. Why you have problem with negative numbers, man? Anyway, so what is the true? I did. No. Anyway, let's go on again here. Now, look at this one. We have here some number 2, 4, this and this. Again, we have some kind of this here and this. Again, this place and right here. Okay, we have here some number, and really this is just this can contain a fractional number, it can contain a negative number, really it can represent also positive number. There is no way to stop it, so it can represent everything, friends, everything, because this is just bits, binary data. So we are representing all our life in computer, in digital place, in digital state. We are representing with these bits 0 1 0 1. Now in this time I saw, now we have different computer, so they are speaking about it like quantum computers. Again, the process will be between 0 and 1, but there is will be some more points. I mean, it's normally in normal computers, standard computers is also, you can think like modern computers. We have 1 and 0. It can be 1 or 0. We have two patterns there, so possibility can be two things, 0 or false. So no, 0 or false, 0 or 1, true or false, yes or false, yes or no. But in quantum computers, I think will be some fractional place like 1 divided 4, 1 divided 3, 1. It can stay every place and it will store lots of data. I think I will check it. This one is true. This is the keyword here. Positive, negative. Let's take it good place. Negative and fractional number. Fractional number. This one is true answer. The other ones is really wrong. Okay, now let's look at the last question here. Let's do together. Consider, that's right, 5. I think the other one will be 4. What we did, can we put? No. Oh, just put there 4. Man, what we are doing here? This is crazy. Oh, maybe 3 also not there. Oh, yes, 3 there. I'm okay now. Okay, let's for 5. Let's write lots of things again. Consider a computer that uses 5 bits to represent positive and negative negative integers integers using using 1 bit for the sign every time operators for the sign and 4 bits. You have to think very fast. 4 power of 2 minus 1. You know that, right? Because the first one is just can be 1 or 0. The other one is going like 2, 4, 6, 8 all the time, multiple of 2. The first one is 1. For that, minus 1. This is our formula, right? We are saying 2 power of 2 minus 1. 3 power of 2 minus 1. Anyway, I think you remember. So, I think, yeah. And 4 bits for the actual value. For the actual value. Okay. Which of the following operations would result in integer overflow? Yes, we have overflow problem here. Let's look at that, man. Overflow, something will be very more than what we are looking. Then just you have to define it. Really, you have to indicate it. Then you have to say, hey, this is the wrong, man. This is not true. Say, not that there are there are two answers to this question. No. Yes, come down and say A is like B is like C is like E is like E is like no no. This one is 8 plus 2. E is like and F is like now I will draw because I have to do it. Now we have 5 bits. 1 bit I'm using for the sign. It will be operator. It can be plus this one or this, really no matter. 1 bit for it. Okay, let's say for it one bit. Now we have 4 bit. 4 bit. 4 bit will be what power of? So 4 power of 2. Yes. Now 4 power of 2 will be what? 2 times 2 it's 4. 4 times 2 it's 8. 8 times 2 is 16. Minus 1 have to be because our first bit can be 1 1 or 0. The other one is going like 2 4 yes 8 all the way like multiple of 2, But first one is just 0 or 1. For that, we can say this is our formula. Just make it now. This is 16. 16 minus 1 is 15. Okay? 4-bit can represent 15. Okay? So we are looking for 15, but it's asking us, we have overflow here. So something will be up than 15, or yeah, if down, it's really not problem. But if up, if more than 15, then we have problem. The first one is 15. This is true. The other one is wrong. Look at that. This is 16. So there is no minus 1. Anyway, why? This is wrong. That's selected. This one is true. True. This one is wrong. This one is 16. Let's put it. This one is 15. This one is 8. This one is true. So we have B and D wrong. This is more than 15. I told you this is our rule here. 1. So this one is can be 0. So really not important. We're just representing it with the sign. This is all finished. Thank you so much for joining here. This is all our question and all our solution. This is digital information quiz 2. Let's start. Not now. So after this, we will start new subject. It will be amazing. I'm waiting you there. I'm so really if I'm doing something wrong, but just I want to share my experiments. If there is something bad, just forgive me and really don't argue with me, and just feel better. What do you want to do? Okay, if you want, just go out and don't watch me, or I don't know what you want to do. Just do it. Just I'm it. I'm this. I mean, not I'm it. This is wrong grammar. All right. Thank you so much. See you later. For now, have a good time there.